Hello everyone, my name is Rohit Saxena. I am working as a security consultant for a smart city project, securing their 5G private network, IoT network and cloud network. Prior to this, I have worked with multiple telecom network operators for securing their network, which includes 2G, 3G, 4G, 5G and IoT network. Today, I am going to present the approach for securing 5G network. This presentation has been co-authored by my colleague Kamal Singh, who also worked with several telecom operators and banking sectors for transforming and securing their networks. He is currently also pursuing his PhD in network security and automation. Our approach for securing 5G network will be based on primarily two security principles, namely zero trust approach and defense in depth. Before talking about 5G, let's have a quick look on the journey from start of wireless network to 5G. What has changed with 5G till date? From this table, we can see how we progressed from 1G to 5G. When we started with 1G, it was analog switching, that is voice only. Only voice was there was no data. Then came 2G or 2.x-G. With a speed of few kbps in addition to voice, there was data. This was the first time when the world saw data, the wireless network. It was having mobile internet, low speed streaming and email services, some basic services that is. After 2G, it came 3G with enhanced speed in Mbps, having voice, data, multimedia, smartphone applications, fast web browsing. And then we saw 4G. With 4G, we can see speeds up to 1 Gbps. High speed, high quality data, multimedia, streaming, etc. Also, the technology landscape moved towards virtualized platform. Before the virtualized platform used from 2G, 3G and all, it was all monolithic proprietary software and hardware mostly. But in 4G, it was virtualized platform with latencies of 50 milliseconds to 10 milliseconds and IoT density of 10,000 IoT devices per square kilometer to 100,000 IoT devices per square kilometer. That is what 4G technology as a technology was capable of carrying. And now in 5G, we are experiencing speeds up to 10 Gbps, super fast mobile internet, low latency network for mission critical applications such as IoT security, surveillance, healthcare apps, HD multimedia streaming, etc. Technology landscape has also changed in 5G to cloud native, microservices based, making it more flexible and software based. In 5G, we can observe latency of only 1 millisecond as compared to 10 milliseconds in 4G, and IoT density of 1 million IoT devices per square kilometer as compared to 100,000 IoT devices per square kilometer. This is a huge shift. So, here we are in 5G. But 5G is not all about speed and data for internet. 5G has changed the world of wireless technologies. 5G is no longer a technology for making calls and data browsing over the phone alone. Rather, it has become an enabler for a connected world with advanced use cases for almost every industry, such as manufacturing, public safety, healthcare, public transport, energy, and utility, automotive, media, entertainment. Three main services offered by 5G, namely three services scopes we can say. The first one to start with is enhanced mobile broadband or EMBB, popularly known as. That is used for the applications which require high data speed, and 5G can provide data speeds up to 10 Gbps. Then the next comes as URLLC, that is ultra reliable and low latency communication. This is for mission critical services where latency is not desirable, such as e-healthcare, autonomous vehicles, industrial automation, cloud gamifications. Just imagine any latency in any of these mission critical services will lead to disaster. And even means if we talk about the cloud gamification, any lag or latency will not give us a good experience. The next is, and the last one or the third one is MMTC, which is Massive Mobile Machine Type Communication. I recently read somewhere the most popular prediction for the number of IoT devices will be anywhere between 6 million to 20 billion connected devices by the end of 2016. So even this will be less. If anyone is wondering on these numbers, I can tell you from my current experience that currently we are working to accommodate anywhere between 35 million to 70 million devices in one smart city alone in next 5 to 7 years. So it's going to be massive. We will need 5G or beyond to support that. Having said that, we can see 5G will be used for many technologies, services, mission critical services, and it needs to be secured against all sorts of threats, leading to service interruptions, loss of confidentiality and integrity. Well, there are some security challenges in 5G. Why is 5G is more vulnerable? Many things have changed which makes 5G more vulnerable to attacks. New attack surfaces, more exposure, change of technology. Here, in this slide, we can see some key changes from earlier technologies which make 5G more vulnerable. The first one to start with is the distributed architecture. Earlier, that setup used to be very much centralized and not exposed, but now the edge computing, network slicing, etc., and the use cases to cater to high-speed requirements, the architecture is no more centralized. It is pretty much distributed, spread across the area, leads to increased threat vectors. The next factor will be virtualization. And virtualization, it is no more a proprietary solution and monolithic hardware, which was the case earlier. Being virtual, there are increased cyber susceptibilities in securing cloud-native architecture. The use of new technologies and multiple services or solutions makes it challenging. Next is the proliferation of the IoT devices. This is a very new attack surface because earlier it was not there, it was not prevalent earlier. Tens of billions of devices with different makes and models, many with low inbuilt security feature, non-hardened software or firmware, not so well-defined supply chain. I have come across a case where there was a particular model of CCTV camera, the firmware for which was infected having malware, and it was generating so much user plane traffic that it brought the UPF. UPF is the user plane function for 5G. It brought it down, leading to a DOS, denial of services, for a significant amount of time, which is not at all desirable, by the way. The next is the high bandwidth and the high number of devices. With high bandwidth and the huge number of devices, the security monitoring becomes overwhelmed and equally complex. The next one will be use of open standards and open source softwares. Use of open standard and open source software introduces new risks due to issue in the in the supply chain. Insufficient testing, poorly written codes, and built-in backdoors. And last but not the least, the confluence of new and the old technology. Multiple technology convergence means when we are putting 5G, it has to be compatible or communicating with the earlier technologies like 4G, 3G. So multiple technology convergence, threat migration between technologies like 4G, 5G, 3G makes it more complex. So these are the few factors that bring security challenges to 5G.
Defense in depth and zero trust are two important security principles that organizations use to protect and secure 5G networks. Let's have a quick overview of what these security principles mean. Defense in depth is a security strategy that uses multiple layers of security controls to protect against a wide range of threats. The idea behind this method is that if one layer of security fails, there are other layers in place to stop the attack or limit its impact. In the defense in depth strategy, each layer should have its own set of controls that protect in a different way, which means there should be multiple layers of security for holistic protection. On the other hand, Zero Trust is a security model that assumes no one inside or outside of an organization can be trusted. Zero Trust means that every user and device that wants to use a network's resources must be inspected, no matter if they are inside or outside the network's perimeter. It is an approach to security that looks at the whole picture. It includes identification, authorization, providing least privilege to users and devices with network segmentation, monitoring, and logging. In summary, defense in depth is an approach to security that uses many different controls at multiple layers. Zero Trust, on the other hand, assumes no one can be trusted and checks all users and devices that try to access resources. When these two security strategies are used together, organizations can create a strong security posture that protects them from a wide range of threats. Let me give you a few more details about Zero Trust model. The first is microsegmentation. The Zero Trust model employs microsegmentation to create no trust zones within the network. This means that the network is divided into smaller segments and access to each segment is strictly controlled. Each segment is treated as an individual entity with its own set of access policies and controls. This approach limits the attack surface, as even if one segment is compromised, the attacker will not be able to move laterally across the network. The next is identity and access management, which is a key component of the Zero Trust model. It involves authenticating users and devices before granting access to network resources. Users are required to provide multi-factor authentication such as a password and a one-time token or certificate to verify their identity. Access is granted only to the specific resources that the user needs to complete their tasks. For every connection, we ask the user to validate who are you. No implicit trust. This is achieved by use of certificates and mutual transport layer security protocols. And least privilege with authorization is the process of determining whether a user or device has the necessary permissions to access a particular resource. In the Zero Trust model, authorization follows the principle of least privilege. This means that users are granted access only to the resources they need to perform their job function and no more. The Zero Trust model also follows the principle of can you do it, which means that users are granted access based on their job function and responsibilities, not on their job title or rank. In summary, the Zero Trust model is based on the principle of never trust, always verify. It employs microsegmentation to create no trust zones, IAM to authenticate and authorize users and devices, and authorization to ensure that users have access only to the resources they need to perform their job function. By implementing these measures, organizations can reduce the attack surface and mitigate the risk of cyber attacks.
Now, before looking at the approach for securing the 5G network using the two principles discussed earlier, let's have a quick look to understand the 5G network and the domains it has. Starting from left in the current slide, we have the endpoint, which can be anything from a mobile phone to IoT devices. I have also mentioned some possible key attack methods or attack vectors. The devices, as I highlighted in earlier slides, can pose a major risk. It can be due to a low security posture, infected firmwares and applications, backdoors, which can lead to anything, including DOS, denial of services. The next domain is the air interface, which is essentially the 5G air interface. That is the connection between the devices and the radio node. 5G is pretty secure by design for that matter, but the security features need to be enabled and implemented. Many of us might have heard of concealed MC in 5G, which is the new security feature. which protects critical information over the air. I have come across many deployments where this has not been enabled actually. So if you will not enable, you are not going to enjoy the security. So because enabling this may require of some major changes like the change of the SIM cards. Next is the radio base station, which is also called G-Node B in 5G. We also have ORAN, which comes with its own flavors and new security challenges, but in a nutshell, it should be protected against illegal user access, and all interfaces and communications should be encrypted and protected. Next comes the edge function, that is functions hosted at external data centers, the external places outside the data center, the main data center. Sometimes they are not even under our control, let's say third-party data centers. Then comes the most important piece, which is the heart of 5G network, 5G core. It has many attack surfaces now, especially when now it's been exposed to external applications, earlier which was not the case. And last is the external interfaces, let it be for roaming purpose, that is a CPP, that is the interface which is used to connect to external 5G operators or interconnections with IoT applications, API communications, etc. Now we will see the key controls to protect the 5G network using the zero trust and defense in depth principle. We will cover it domain wise. Starting with the first domain from the left side, that is the endpoint protection. Endpoints, as we discussed earlier, it is no longer only the mobile device used for making calls or data usage. It can be any of the IoT devices, let it be a sensor, a CCTV camera, anything, a drone applications, a crane operations, anything. With the variety of devices, we should always ensure that only authenticated devices are connecting to our network and making use of the communication channel. So we should be making use of certificates to authenticate the devices to the network. This will help us in avoiding any of the rogue devices making use of the network, and also the IoT applications. This will make sure that only authorized devices are getting connected to the network and to IoT applications, and no rogue devices get to use the network using stolen credentials or passkeys. There are ways to check the integrity of the firmware of the devices using the certificates as well, which if supported by the devices can be used. The next domain will be the air interface. 5G supports various algorithms for confidentiality and integrity protection, and they should be enabled over the air interface. So they are just a configuration parameters which needs to be enabled on the network side. The next domain will be the radio base station, which is essentially the radio tower which we see. In 5G, this is called as G-Node B. Whenever a G-Node B is connecting to the 5G core, so the G-Node B, in order to communicate to the main data center, it needs to be connected. And before connecting, there has to be an authorization. In order to avoid any rogue node to get connected to our 5G core, which is the heart of all the 5G functions and 5G network, there should be a strong authentication in place, and a PKI based authentication is always recommended, and it should be enabled for G-Node B authentication to the network. Once the authentication is taking place, the communication over the interface should be using secure protocols and preferably IPsec for encryption and integrity of the communication. This should be supported by having a proper identity and access management solution for the people who are accessing the node and security monitoring. That is from the operations perspective. The next domain which comes in line will be the edge computing, if at all it exists. So there might be some use cases where there is no edge deployment, but yes, in 5G mostly we are seeing edge deployments. So for edge, the control will really depend on the way it has been deployed. There can be n number of models for deploying edge, but it should be protected against multiple attack types, like anti-DDoS being one. Have another layer of protection for encrypting the interfaces for confidentiality and integrity check. Proper access control for firewalls or IDS IPS. This will be essentially required because at edge, many times the edge functions need to communicate with external applications which we do not have any control on, and sometimes we do not have any visibility as well. Now, next comes the main 5G core. This needs to be protected as this is the main set of functions communicating over service bus for all the signaling and control plane traffic. So the 5G core will also have multiple security and the layered security, including the access controls, logging, and monitoring. A very key control I have personally seen very effective is using mutual TLS for all the communications. This will require PKI or any of the certificate authority, let it be a private CA, to issue certificates to all the functions which will authenticate each and every session and communication. Not only the authentication, it will be also used for the encryption part of it. It will ensure that only authorized functions can communicate and no rogue communication is allowed. There are various ways to automate it. Since we are discussing this, means mostly there is an orchestration like Kubernetes or something which is used, and they do support protocols like Acme for automating the certificate distribution and lifecycle management. And lastly, the external communication, that is using APIs, external communication to let it be an external 5G provider or an IoT application, which will be using either an API or other protocols like SCPP. This should always be using a proper gateway, let it be an API gateway or an SCPP firewall, providing all the authentication, encryption, and also protecting against application level and content level attacks. So this is on a very high level ways to secure 5G network using zero trust and defensive depth approach. I hope you find it useful, and if you need any more details on anything which I presented today, I am always reachable. Thank you very much.
Anyone have any questions for the presenters? They are available, I'm told, online. Are any online questions for them? If not, then thank you very much for being willing to make this presentation to us.